so on, because of environment, because of other reasons. Okay, it was 20 years ago, but also in the first analysis that we 1973 with cultural vessels, where we know about the wind, the effect of this wind, how big is this area, and so on. And in the last 20 years, we have found out that was 10 years ago, that after 1973 there was about 20 specific studies in areas, which is the reconstruction of a new railway station, a new residential area, parks and so on, or some other areas to build up. Here's again the stadium and so on. Here's the stadium. Here. But it was only going in detail in microclimate, and okay, we checked something, and this unit influence. So, and our idea from the meteorology side is that if you want to run something like that, first you have to know the background situation, and then you can run something for a small scale. So we made some pressure to the mass media. The mass media to take over all this opportunity and say scientists don't agree with that and so on. And there was a pressure, and then also at that time was announced the master plan 2020. And finally, they gave 250,000 euro, how much is it, about 10 million, no, $100 million. City government spent this only for moderation to make the people understand about the importance and why they don't do that. And then we get very angry and ask them, what about us? We don't get money? Finally we get some peanuts to do the analysis. And the idea was not only to focus on a specific area where there has to be reconstructed or constructed new, but first to do background analysis. And we used here the procedure. And first we started to see and collect all the things that was existing, like long-term measurement data, biotope maps, digital terrain models and so on, also the buildings model and so on. And then first we put all this together, produce or select the appropriate method for that, which was measurement campaign, air pollution calculations, or thermal flights in order to get the infrared pictures or something like that. Produce the primary maps of all this information, and then we aggregate the most relevant things that we thought, or what's from the municipality demanded. And so that was the bioclimate modeling, the air pollution, based on PET maps for day and night, and maps for air pollution. And then we had a problem. How to do the synthesis, how to do an integral approach if you produce only a map of heat stress or something like that, or if we produce air pollution. The city government will tell us we don't need that, because they want to have finally a planning advisor's map. They want to see a map, can here I do something or not? Okay, and then we realize that this is not only important to have basic information, but we have to check all the areas that is existing and see how often they are used. It makes no sense to have somewhere an area nobody uses that, and we say here's heat stress and he has to do something. And then we put something like an effect analysis, produce effect maps. Finally, consider all the information in a climate function map in the planning advices. That was exactly what was demanded. And in order to do that, first we check how are the background conditions concerning climate or bioclimate. It's not so often, but I have to apologize that this is not the reality. This is because of modification of the wind. It's not 0.7% per year, but it's 4%, which is about 15 days per year. Okay, and then finally we make the measurements, put all this procedure together, realize this in a map, and the resolution that we use here is the resolution demanded by the farmers was 50 meter resolution. Okay, this is the map. You see anything what is blue, it's outside of the city. We have here starting from green, 26, 28, up to 40, 45. That means we can count here specific areas where the heat load is high. That means here something has to be done, or if you want to do something in that kind of area, that means you will have an increase. That was the first result concerning bioclimate or heat stress. And then we put this basis for heat stress, cold stress, air pollution, produce all this map, And we make also air pollution. I think air pollution is not, you're not so interested, so I skip that. But we produced also a map, because the problem in Freiburg is the highway. We have only one factory somewhere here, somewhere about here, but it produces no air pollution. The situation about air pollution was very easy. And then we produce this affect map where we have the actual load and the probability of state of humans, bring this also together and produce a map based on the factors activity, spatial relation, temporal relation, alternative A, and the influencing parameters. This was something, a selection criteria, put them all together, produce the map, and finally for the day we know that the situation has to be done more realistic and more detailed in the areas which are red, which means the effect is very extensive or distinctive and so on. This is for the night. All this information flow first in a climate function map where we have the climate conditions in a city. That means green as forest areas, urban areas. This is about ventilation. But this wasn't enough for the planners. Finally, they want to have the combination of all of that, which we have here. This is the planning advices map. And we have information about air pollution, if the the air exchange is polluted or not polluted, cold air flow, what about the flow in the surrounded areas and so on, what about the mountains, the influence of the local wind system, and so we quantify the build-up areas in a resolution of 50 meters, about the air exchange and other climate relevant areas, and finally we had a map or information about the conflict or the basic background stress and areas where conflicts can occur. That was the final map that we produced, not by me only. There was a group of 7 or 8 people with companies. There was a hard work, about 1 year, with less support from the government. That was 2003.
That was 2003?
That was 2003. I was happy about that. The project was finished. I applied my models, I applied my method, I developed some tenures, and I got richer in knowledge. And then I have been in 2007, I think, in Japan. Made a presentation about this project because in Japan there is a close relationship in urban planning with Germany. They work for several decades together. Somebody asked me, and what happened after?
Yeah, exactly. What happened after?
At that time in Japan I cannot answer. But now I know. But about 70 places, that was 2008, 2009, has been selected, checked again with a deeper analysis concerning residential, commercial or mixed-use area, and then they make an analysis about 2 scenarios. If there are effects concerning climate so going outside and coming inside, the effect from other places and so on. I didn't know that, but we don't know the results what happened. We know only some examples. This was from a consulting company, and all the information is confidential. But we know that based on this, decisions have been made. At the time was about 70, I think at the moment it was 100. If I ask the municipality, they tell me, yes, we have done something, but we cannot tell you. This is this. Okay.
But this is not putting the building regulation.
No, this is not putting no building regulations. Only if construction. This is other story. Okay, that was about 2009. At that time, another discussion has been started about a specific place in Freiburg, which is the place called the place of the old synagogue. This is this area here is about 600 square meters. This is University Building number 1, University Building number 2, the theater of Freiburg, and this is the library which is reconstructed now. And you have here a huge area, great grass area with some trees. And when you go during summer, during spring and autumn there, during the midday, you don't see the people going for food or the students. They are lying here. Maybe some siesta, recreation or something like that. Okay. And the city wants to reconstruct this area because from the aesthetical point of view it's not so interesting. So, and they want to reconstruct this area, and they make a competence or something like that for architects, and something has been built for new reconstruction and so on. And they want to remove this area, change this area in a multifunctional space. And this multifunctional space has to look something like that. some trees that was in the beginning, some possibilities for the bicycles here, for the students, and you see the pavement will change from grass to stone plates, granite plates, or something like that. Look beautiful. And you will see, and you can imagine that in the last 3 years, 4 years, we had every week something like a headline in the newspaper about that. We will be a back oven or something like that. Anyone will die because of climate. It will be so warm. And many, many things. Finally, after the pressure, the situation has been changed in that way. With a small waterfall here and here, and some trees here. This is not the realistic final plan, but this is how they want about the building. There was a consulting company who give expertise about that, but they run a model, they run some simulations for April and for August. And they find out that in August it will be much warmer. But for the population this was not enough. We also don't agree with that. So some movement has been in the media. Finally, it will be also, this is the theater, the new library, some information about this. This will not take place in the future. But finally, that place will be reconstructed, but not in the first plan, but in a more modified plan. Not so beautiful like here, but in a similar way. Okay, and then I have a student, one of my staff, he's finished now, finishing his master. She asked me, can we simulate that? And asked him, are you crazy? We will need so much time and our models will go crazy because we cannot simulate, it's very difficult and so on. And then we sit down together and thought, we don't want to have the involvement in this political things or something like that. We want to see what can we as biometeorologists, climatologists do in a short time, give only 3 months time to this analysis. How can we contribute not only to have heat stress in summer, but to see more possibilities and give more information to planners. We have the model that I mentioned before, Raymond. But there existed also some other models, and for these models we wanted to see how we can apply, and the restriction that we had was the models that we will use has to be free models, not paid. So not how many models existing in reality, is only 4 models. The last one we didn't use it because it don't deliver us more information, so we used the environment model. We will see results, which is a microscale model. We can deliver anything that you want, but it takes much time. If you want to run 1 day, you need 1 day a good computer run. And then but this model is not a creation of us. We use the Raymond model, which is from our institute, and we need data and so on. When we need also the Sky Helios model, it's a further development of Raymond and so on, but it's not absolutely finished now. We have time for the next year to include more information. Okay. The first thing that we have run,
can we go back down one? What kind of data has to be put in the given models in order to explain it?
Yeah. In order to run this model, you need temperature measured, or from a weather station, humidity, wind speed, radiation, or cloud cover. If you don't have radiation or cloud cover, problem is solved by Raymond. And finally, you get all this information about sun orbit, sunshine duration, shade, and all the thermal indices like PET, UTCI, and something like that. The environment model delivers something like PET, finally, but also wind distribution, something like that. Sky Helios is a helping engine in order to produce some additional information in the moment. In the moment delivers only sunshine duration and so on, but next year we'll deliver also wind. In 2 years we'll have all the information that we have also in Raymond, but with less data. This is the restriction that we have. We want to use only less data. Okay, and then we use these 3 models, and the first that we made for this area that we have seen before is we analyzed the most important meteorological parameter. Can you imagine what this parameter can be? It's the sky view factor. It is the free horizon. It's not a meteorological parameter in reality, because it's not meteorology. But it's the effect of the buildings and the obstacles that I have which modify sun orbit. and we know that most energy that we use, or that we need, and which makes the biggest modifications from the sun. And we check that this is now, and this is now, and this will be in the future. These are some trees. This is again building number 2, building number 1, and the library and the theater. We check that the sky view factor is increasing based on the new construction of the area. That means we will have more radiation. If the sun sky view factor gets higher, that means more radiation. If it gets lower, that means shade and something like that. And then we focus on that, and we thought where we will see less changes in the future, maybe here, here, or somewhere here. And then we analyze for 7 specific areas, places, point 1 to point 7. We analyze the sky view factor there. This is a picture, it's a hemispherical picture in polar coordinates and so on that we have. For the green area in the middle, and this is the bus stop. The distance from here to here is 50 meters or something like that. And so this is the way that we see the sky view factor, and it's spherical. And I will skip to the next image in order to see the changes. And please give emphasis here and here. Here changes at most. And point number 7, the small trees are not big trees, but small trees. That means I will have the influence. If I check this concerning the hours that I have with heat stress, and point number 7, at the moment I have the last one, 2004, in the future will be 330 hours per year. It's an increase of 126 hours. Okay, you may tell me this is only 5 days or 6 days. But please transfer this 3 times. This is more than 15 days. That means the change will be more than 15 days concerning this issue. That was the first result that we counted, but I mentioned before that we want all this information to transfer to the background situation. We analyze based on the data that we have from our station that I showed before, this distribution. We analyze all the year, made with Raymond the transfer of radiation from the station to this area, to these 7 points, but also we make a modification of the wind. We adapted the wind. And we see here the situation in terms of frequency. That means blue means that it's very cold during the winter, and here warm, hot, and very hot conditions only about 5 to 10% during July. This is the situation that we have now. But after the modification of the new place, especially in the summer, we see an increase in the extension of period in the period, but also in the frequency. And this is exactly the 150 hours or 130 hours that we have per year, what it makes. This is here the increase, but now having all this information based on the background analysis for all the year, we can deliver an answer how often something will take place. A meteorologist finally will deliver you the something like a mean temperature or mean heat. So we make it in a different way. The next step that we made, we used the ENVIMET model to calculate this for a heat wave. And we see here, black are the buildings, and here are the range of ET. At the moment, in the place where green is about 40 in summer, 40, 45 and so on, but not in all the areas. And for the future, this will be increased up to 10 centigrade. If you deliver, and if you think back to the one image that I show you concerning the thermophysiological stress classes, is about 2 classes in thermal stress. We know that this model has an overestimation. So we have to be careful about the results, but we know where the problems of this model are, but we know about how the distribution is now and how the distribution will be in the future. This is the example how we can, with models, and also we need data. This model needs no data. It runs automatically. For our models we need data. We have another philosophy in the model. So, what can we do now? Do you have any idea how we can solve, or how can we reduce heat stress in cities? It's the same in Taiwan, the same way.
Trees.
Exactly, trees.
Always trees.
So we have. Let's look behind the effect of trees. They have positive aspects and they have negative aspects. I have to apologize, I have to be honest. One negative thing is here missing, but I will don't talk about that. It's about her. But this is another story. If you think about that, the trees, of course, the tree is a carbon sink. It's beautiful, aesthetic to have trees in the city. Wildlife can exist there, except humans, also wildlife. Human health improvement, greater privacy, humidifying effects, increase of property values if you have trees in your property, reduce heat island effect, reduction of soil erosion, sound buffer. You see many, many things. And the negative aspect is the damage to property if a storm happens, leaf and fruit fall, and also you have to pay for that. Oh, I forgot one. Shade. And this is exactly because I belong to a faculty called Faculty for Forestry and Environment. I love trees. We make an analysis during the 2000 heat wave. There is a state in Germany called Bavaria. You know it from Germany, the beer festival or something like that. This is in Bavaria. I was 15 years in Bavaria. And they have forest stations. They have some stations inside the forest and some stations outside the forest. And for the first 2 weeks in August 2003, when the heat wave take place, we got the data. They asked us to do some analysis. And if you check now, this is the hours from 0 to 24 hours, or the day, all the day. If you check the temperature inside the forest and outside the forest, we see only less differences. Okay, 2 centigrade, 3 centigrade, something like that. Not so much. During the night, some differences, it's lower outside and so on. But if you take now one of the thermal indices shown here, the PET, you see a huge difference. Outside the forest, during the day, we have a difference about 10 to 15 PET. This is inside. Inside is about 30, something like that. While outside is about 40, 45, 50. This is measured. Then calculating the framing. Some modifications I admit. That means producing something like a climate manipulation, planting more trees, we have the decrease of heat stress. The situation during the night is a little different. We as humans make something wrong. Usually we have to be during the day indoors and during the night outdoors, good for the human nightlife or something like that. But nightlife is also indoors. Usually we have to be outside. So the difference is not so huge. That means the target is now what can we do during the day in order to reduce the heat stress outside. I'm not talking about it. I think this is example delivers direct numbers in order to know what is the influence of it. Then we make an additional analysis based on conditions which will take place in the future, and then we use the PET frequency distribution for Freiburg, and then we make the following. We take data from the climate models for the future and distribute them for the midday, where people are standing outside, and then we run the PET distribution for Freiburg. We see it's about minus 22 up to 50, 52, 51 or something like that. The blue one is for the period of 1961-99. And then we compute the conditions for the future, and we see a shifting, a clear shifting in the minimum conditions, but also in the maximum conditions. You see, it's a clear shifting to higher conditions. And then we thought, what can we do? The first idea was, which is the parameter, which is the factor who influences, which can be mostly influenced by planning, architecture, and some other things. This is radiation. That means sunshine. If I remove the sunshine, that means I will plant trees and sunshine will not, or radiation will be not so strong, and simulate this for the the conditions for the future, but with less radiation, we have solved the problem. This is the dreamland. We have solved the problem with heat stress in Freiburg. And then we thought, after radiation, that means shade, which is the factor or the parameter which can mostly influence by configuration and trees and something like that, we know that it's the wind. We make the same simulation with 2071, 2100, but we reduce the wind only 1 meter per second. And you see we have an increase about 5% from the original situation for the future. And based on that, we increase one more time the wind. That means we make it more windy there. And we see there is a decrease again of the situation of about 3%. It's quite easy. It's a very simple example how trees, how radiation and wind modification, both of them can contribute. Of course, this is only an analysis. In reality, we have to do the configuration inside, amount of trees, blah blah, and many, many other things. But we have so many young people who can do this in the future. Okay? So, I think I have shown you several examples what can be done with climate, the methods that we have, the models that can be used, or we have to be, of course, careful with the models. And before finishing, I have a picture of the vision of an urban planner. It's Babette Köhler. She's responsible in the urban planning department in Freiburg. And we asked her to present us her view, and she showed us only this picture. They think about shade. We talk about that. They think about ventilation. Trees, big area, no traffic, less air pollution. This is the tram, of course, this is the cars. Public transportation in order to reduce air pollution, and some possibilities here for water flow, for the rainwater collection, but to flow, and not to have a flash flood or something like that. But we talk about these issues, shade and ventilation. Do you see here, these are the trucks? It's green. You have noise reduction also, but also from the aesthetical point of view that we talked earlier. Okay, this is the view or the vision from the urban planner. I would like to draw my conclusions. We have to keep in mind that concerning climate and also climate change, the effects that we have take place at the local level, that means in the microscale. That means we cannot change the global situation, but we can change our living conditions by modifying the microclimate. Many information are existing. We have many information from applied climatology which can be easy transferred. I show you several examples here. They are existing. And then we have to keep in mind that climate is only one perspective, only one facet. Air pollution, noise, UV has to be also considered, and we have to think also about the synergy, the combination of all of them and how to quantify them. The show is concerning air pollution and effect analysis. We have to keep in mind that future conditions will be more important. The pressure is getting higher, and there is at the moment not a movement, but there's something new. In the past, in the building the building code was climate and air pollution mentioned as something has to be done about. But in the new